If we just put the same thing in a function, then what will happen? It will just it will be triggered only when function is triggered. Okay, it will be triggered only when function is triggered. If function is not triggered, it will not trigger. It will not work. That means if you okay put this thing within a function, okay, for example, how can you declare a function? You can declare a function by using def, right? Def is the keyword for declaring a function. Function name hello, okay, and I put this thing over here. So if I put it over here and I will execute it, this is not going to execute because this is now dependent upon the function, and the function is what? Hello. Okay, you can trigger it, you can just create it. So I am getting no output, right? So now if I call hello, this is called triggering of function in Python. So as many times you call hello, as many times you will get the output. Okay, suppose you are having a 5 lines of code or 10 lines of code or 12 lines of code, and you know those lines of code are going to be used repeatedly. Okay, you are having 50 lines of code and you know those 50 lines of code are going to be executed repeatedly. So what will you do? You will just create a function, and within that function you put those lines of code, and you can call those things repeatedly as many times you want. Okay, this is called function in Python. Now function comes with some variations. Okay, function comes with some variations. What are the variations basically? First is ideal function, you can say. Okay, ideal function, or you can say, or without any parameter, a function without any parameter. That is called your ideal function, right? Second type of function is known as what? Parameter based function, right? Third type of function is what? Multiple parameter. Okay. And fourth is known as what? Return type function. Okay. So each of them is having different uses. Okay. So what is ideal? The function that we have created is ideal function. Why it is ideal? Because if you trigger this function for 1,000 times also, then also it will give the same result. It is not going to change its result. Okay. If you execute for 1,000 times also, then also it will give the same result. Now what is parameter based function? The parameter based function are those kind of function which will change its result, or which will just make a change in the output. Okay, whenever you change the parameter in the runtime. In the runtime, whenever you change the parameter, it will change the output. What I exactly want to say, look here. Look, I have to create a function, right? I have created a function, right? Name. Okay. Print hello. So each time it is going to print hello, that's for sure. Now what I will do, I'll just put a parameter over here, x. Okay. And then comma x I will pass. So this is called parameter based function, means a function which will be triggered with a parameter and will change the output whenever you change the parameter. Like I am passing Bipul, so it will give you hello Bipul, right? Name Google, so it will give you hello Google, right? Name Pawan, so it will give me a hello Pawan. So this is called parameter based function. Got it? The same way you can create multiple parameter based function. Okay, like it's a single parameter based function. The same way you can create a multiple parameter based function. For multiple parameter based function, what you have to pass? You have to just define multiple parameters, right? X comma y and y. Hello X and Y. So it will be like name Bipul, comma Rahul. Name Pawan, comma Gopal. Okay. So I am taking it for the two times, and what I'm getting two times, the output is different. Okay. So this is called multiple parameter based function. The same way you can use multiple parameter based function for any kind of arithmetic calculations, addition, subtraction, division, multiplication, anything you can do. Right. So we have seen ideal function, we have seen the parameter based function, and we have seen the multiple parameter based function. Right. Three things we have seen. Now the third part is called return type function. What is return type function basically? DEF, I'm making a function ABC and I'm using two parameter x comma y. Okay. And then I'm doing a print x plus y, or I'm doing what? Yeah, z equal to x plus y, right? And then print z. Got it? So whatever you pass, it will just add those value, right? So I'll pass ABC 4 comma 6. It will return what? 10. Okay. Now I have to operate, I have to just use certain operand. What operand I have to use? For example, multiplication. Okay. Multiplication 2. So if it is 10, then output should be what? 20. Right? If it is 10, the output should be 20. But if you execute it, it will show what? Exception. Okay. It is showing exception unsupported operand type. Why it is showing unsupported operand type? Because on this function you can't directly apply operand. Why you can't directly apply operand? You can't directly apply operand because it's a normal function. It is not a return type function, and this function is having no value that it is carrying. It is itself having no value, that is being there in the function. Okay, means this is just doing a task. This one is just doing a task, performing a task, but itself is having a value that is null. That is null, not even zero. That is null. Okay. Why? Because it's a return type. It is not a return type function. So what we have to do? We have to create a return type function for it. So it can be just return z. So whenever you have to do any kind of operation over a function, you have to create a return type of function. Got it? Right? So please do take care. When we need return type of function, we need a return type of function whenever we have to, when we need to operate over function after calling, right? Whenever we have to operate over function after calling, what we have to do? We have to create a return type of function. Got it? So this is about functions part of Python, right? Is there any doubt that you are having with the functions? Please ask, go through the things. If not, then it's all right. If there, then you can just ask. Nothing? No doubt? Okay. So basically, this is about the function. Then with the function, there is a declaration also. There are two types of declaration are there for the function. One is called local declaration, second is called global declaration, right? So what is local and what is global? If something is defined within a function, that type of declaration is known as what? Local declaration. Okay. That means if I define something, I have created a function over here. Please do take care. There are two things associated with a function. One is called local declaration and second is global declaration, right? Okay, two things are there, local and global declaration, right? So what is local declaration? Local declaration is something which is declared within the function. That means if you define this thing function, a function is defined as x y z. Okay, k is equal to 4, l is equal to 5, print 4 plus 5. Okay, a function, right? And there is another type of function as well. So this is a function I am having. Right? So k is declared, l is declared, right? But if I call, if I want to operate k and l independently, it will not get operated. K plus l I want to operate, it will not operate. And what it will show? It will show k and l is undefined. Okay, but k is not defined. Okay, why? Because k is defined within a particular function. So this type of declaration is known as local declaration. So whenever something is defined within a function, that means those variable can be used only within that particular function. Okay, we can't use those variable outside the function. This is called local declaration. Please do take care whenever you need to define global and whenever you need to define local. If you have to make a variable kind of any variable is there and you have to limit the use of that variable, you want the use of that variable should be limited within a function, then please define that variable as a local variable, right? But if you define some variable, for example, d is equal to 4, a is equal to 7, okay, def def any function like qwe rty, any function I am defining, okay, print d plus c. right? So this function will operate, it will operate over D and E. It can do the multiplication, subtraction, division, whatever you want. D multiplied by E, it will do it, right? If you want to operate independently, D and E, then also you can use it. D divided by E. Then also you can use D and E because D and E is defined globally. Okay. So if some variable is defined within a function, you can't use that variable outside the function, okay, or without calling the function. Okay, if some variable is defined outside the function, it can be called anywhere, any part of the world, and that is called global declaration. So you should take care of local and global declaration, right? So this is about the basics of functions for a Python. I hope it is clear for all of you. Is there anyone who is having any sorts of doubt? Please just mention your doubt over the chat box. If not, then we'll proceed for the next part. I have shared the link with you. You can just refresh the link. If any code, any syntax, any command missed, just refresh the link. You will get the command and syntax. Done. Shall we proceed for the next part? Okay, I guess we should proceed, right? So this is about the Python's thing. Okay, hope all of you got a kind of image like how Python works and all. All those who had worked on Python, they had a good revision. If all of those who had not worked on the Python, they also now they are also on the same floor. Okay, they also know all those things of Python which are important for the ML codings and for creating an algorithm using the Python. Okay, calculation, subtraction, division, multiplication, all of us know, right? So now we'll proceed for the next part. Okay, we'll understand something that is called file handling and exception handling is something that we'll discuss uh, later on after completing a particular part. Then we'll discuss those file handling and all. When we access a file, at that time I will discuss those things. Okay, the next thing that I'm going to discuss with you is the packages, or you can say libraries. Okay, which kind of packages, web packages, web libraries, or what kind of packages basically. Okay, so this thing important, we are going to discuss data science and machine learning packages. Means all those packages which are going to help us in data science, data analysis, and machine learning kind of thing. Okay. At the beginning, there are three most important package and fundamental package. One is called NumPy, second is called Pandas, and third is called what? Matplotlib. Okay, so there are three basics of fundamental packages are there that we should understand, that we should know, everyone should know, right? Because this is the most important thing that we should understand how it works. Okay, NumPy, what is NumPy basically? NumPy is something that is used to process or create multi-dimensional or multi-n dimensional basically n-dimensional data variable, or you can say data set. What is multi-dimensional data, or you can say n-dimensional data? Have you seen the matrix? Matrix is the multi-dimensional or n-dimensional data. the mathematical matrix, that is n-dimensional data or multi-dimensional data. Okay. Then pandas. What is pandas? Used to access, process, cleaning, and so many things. You can access, you can process, you can clean. Okay. You can just extract. Okay. What? Data files, or you can say external data files. Okay. If we are having a data files like Excel, CSV, JSON, SQL, any type of, right? So it will be used to access, process, clean. Okay. External data files. This is a use of pandas. Okay. These are the most fundamental libraries. We will proceed and we will see some more libraries as well. But at the beginning, we have to see these libraries. Then matplotlib. What is matplotlib exactly? It is used to plot. What to plot? Plot data values over x and y coordinates. But it is used to plot the data values over x and y coordinates. Got it? So these three packages that we have to understand at very first. Okay, we will start our learning with NumPy. Okay, means NumPy library. Okay, that's why I said Python is used mostly in data science and machine learning kind of thing because of these libraries and because of these packages. These libraries and these packages are very important. Means this helps us a lot. Okay, this helps us a lot. That's why we use Python mostly. Okay, it's not like that just Python we can use, but that's why we use Python. This is the main reason. Okay, these are very powerful libraries. Okay. So the first question, how to import a library in Python? It's very easy to import a library in Python. You have to just write import and the library name. The library name is what? NumPy. Okay, that's it. NumPy as NP. Why as NP? Because later on you can use this NumPy library by using the word that is called NP. By using NP only you can just use it. Okay. So how do we use library? We use library with the functions of libraries. Okay, from where we can come to know about the functions of libraries? I will tell you about the functions of libraries. Apart from that, in future, if you forgot the functions of libraries or you want to, the libraries get updated or new things come to the picture, something get changed, then who will tell you? Official document of these libraries will tell you. You have to just go to the Google. Okay, and on Google, you have to type NumPy official document, not NumPy tutorial, NumPy this, NumPy that, nothing. Just NumPy documentation, right? Or whatever you are understanding. So NumPy documentation. This thing you have to search. Okay. As you search, you will get into a NumPy documentation. Okay, if anything is not working, whatever I am teaching you today, tomorrow, day after tomorrow, if any function is not working in future, please consult the NumPy documentation. Or any new thing you want to learn, consult a NumPy document. So in the NumPy documentation, you can see NumPy 1.13, 1.14 means there are several versions of NumPys are there, and each version, whenever some version updated, something usually change, sometimes not change also, sometimes new things get added up. Okay. And why this so many versions related released, it is because there are certain other things are there, certain other libraries are there, like for computer vision we are having OpenCV. So OpenCV, if suppose OpenCV update themselves, and now OpenCV is not compatible with the latest library of NumPy, or you can say latest version of NumPy, then what NumPy needs to do? NumPy needs to update themselves also. So that's why, means each and every library are basically connected with other library as well. Okay, so there is a compatibility things are going on. Okay, so if you have to know, you have to read the document, which document you have to read. It is NumPy 1.18, 1.17. How can you decide? You can decide by checking your own things. By checking your own thing. Okay, so you have to check print np dot double underscore version. So it will give you the version of the NumPy on which you are working. This is how you can get the version of any numpy, any package, any library, np dot double underscore version. So once you suppose you are working on a data analysis project and your library is not supporting, okay, so you can check the version and accordingly you can change the version, either update or downgrade according to requirement. So it is 1.1. That means for getting the knowledge we have to read the document of numpy 1.18. Okay, so anyway you can read those things later on. Right now I am going to tell you how to use numpy. Numpy will be used mostly or with the help of two things. One is called numpy functions and another is called numpy attributes. Okay, numpy functions, the second is called numpy attribute. What does numpy function will do? Numpy function will just do certain task. Okay, that is meant to do certain tasks. What does the attribute do? Attribute will just give you the properties of the existing data. Whatever the data is there existing in the existing in your all environment, it will just give the properties of that particular existing data. Okay, and function will operate over that data to give you certain output. It will do certain tasks, right? So first thing, how to create n dimensional data, or what is n dimensional data basically. How to create n dimensional data, or what is n dimensional data, right? So you can create a n dimensional data by using numpy library, and the library is what? Array. Array is one of the function of numpy. You can call this array, right? 4 comma 5 comma 7 comma 8. This is your array. You can store this value in somewhere. You can store it in n. Okay, 4 5 7 8. So this is how it works. Okay, 4 5 numpy is basically created for data science and machine learning only. Okay, so it is what it is, something, some array, some sort of array. Okay, so what I told you, you can get the property of a data by using what? Attribute. Okay, properties of a data by using attribute. Then question is, what are attributes? There are certain basic attributes like dot shape. It will return the shape of your data. Dot endim. It will return the dimension of your data. Dot size. It will return how many values are there in your data, right? N dot shape. Dimension. Size. These are common basic attributes of NumPy. Print. N dot shape. Okay. Just give print to each and everyone. Print. N is what? N is our NumPy. Okay. So shape is what? 4 because 4 elements are present. Dimension is what? 1 because only one dimension data it is. And size is what? 4 because total 4 elements are present. Okay. If now the question is, if it is one dimension, then how does the two dimension looks like? Two dimension, just define this thing once more. Right? Give a square. Okay. So I have defined this thing once more. And now this is what? Two dimension. Shape is what? 2 cross 4. Why 2 cross 4? Because total 2 rows and 4 columns were present. That's why 2 cross 4. Endim is what? Dimension, because 2 dimension I am having x and y axis. Size is what? 8 because 2 cross 4 is 8. So is it like if I increase number of row, if I make number of row as what? If I make number of row as 3, will it be 3 dimension? No, it will remain 2 dimension, because if it is a 3 row, it is a 4 row, it is a 10 row, still you are having just x and y axis. There is no Z axis, right? So whatever the number of rows you are having, it will remain what? Only two dimension, right? So don't get confused with if it is getting into, if you are getting something else. Four rows are there, 4 cross 4 16 elements are there, but shape is what? 4 cross 4, and size is what? 16, and dimension is 2. Okay, so this is what numpy is used. This is the first use of numpy. Actually there are lot many things, lot many areas basically where we use numpy, and you will see how by using numpy the calculations gets pretty easy. Okay, so easy means whatever thing that you have to write for 10 lines, you can write in 2 lines. Okay, this much powerful this particular library is, right? Okay, thereafter certain functions of numpy. Common functions of numpy. What are the common functions of numpy? Some basic functions of numpy are there, like np dot sum. It will give you the summation of all the value within what? Within n. N is what? N is our numpy data, right? np dot max. It will give you the maximum of all the value within n. np dot mean. Minimum of all the value within n. np dot mean. Mean. That is the average of all the value within n. np dot arg max. n np dot arg mean. N, right? Oh, sorry. Only the last output it will show. You can use what? Print. Okay. So I guess it's clear. Is there any doubt like how functions are working? What are the uses? Sum is summation, maximum is maximum, minimum is minimum value, mean is average value, arg max is argument of maximum value, and arg min is argument of minimum value. So these are the functions, attributes we have seen, right? Anything you want to ask? Okay, Shreyans understood everything. Anyone else? Right, Parthiv. Okay. So what exactly a numpy is? Numpy is basically a matrix, right? If you have to pick any value, okay, you can pick the value by using the just index properties of your matrix. Okay, that means if I consider this thing, what this thing, this will be a n00, this is n01, this one is n02, n03, like that. Okay, that means the first value you can pick by n 0 comma 0. This is your first value, that is 4. 0 1 5 0 2 7 0 3, like that. Okay, so this is how you can pick the value within the numpy. Then what is 3-dimension data? We have seen single dimension, we have seen 2-dimension, and then what is 3-dimension actually? 3-dimension will be a data in which Apart from rows and columns, one new thing will be added, and that thing is known as floor. Okay, that thing is known as floor. That means it will be like this. K is equal to np dot array. Array is used for creating array, right? 2 comma 3 comma 4 comma 5, 4 comma 3 comma 5 comma 6, 1 comma 2 comma 3 comma 9, right? So this is what? This is my two-dimension array. All of us know this is two-dimension array. Now query is what is three-dimension array? Three-dimension array will be there with one more floor. This is a single floor actually, right? So one more floor will be like, I will enhance one more bracket. Now one more bracket, and this complete thing I will copy, Control C, paste. This is my three-dimension data. Okay. So in this data, what I am having? I am having three floor. It can be two floor, it can be five floor, and at each floor I am having what? Rows and columns. Sorry, rows and columns. Right. So this sort of data is known as what? Our three-dimension data. So in future we are going to read, we are going to study this kind of data, two dimension, three dimension, four dimension, and how to process all this kind of data, how to operate, how to make calculations, and all those things we'll understand in detail, right? Next thing, how many of you have installed, because in future when we go for a kind of a computer vision or something like that, okay, so in that case, local anaconda, or you can say uh, operating on or local system not using this particular collab will be good with, because we are working with collab, will it will internet and all those things will might be there. So I will also recommend that you should install anaconda in your system. It is, if you can install it. Okay. So how many of you have installed either anaconda or pycharm? Is there someone who had not installed, who had already installed anaconda or pycharm and is working on Jupyter? Is there someone? I have anaconda. Okay, Parthiv is working with anaconda. Both, right? Parthiv and Shreyans, even they are having experience. Okay. So what is anaconda? Basically, those who don't know, let me tell you. Okay, anyone else? No. Look, what is this anaconda and PyCharm I'm telling about? Actually, we are working with Python, right? We can simply install Python 3.5 or 3.6 and can code. But the challenge is with conventional Python, we will not get these packages, the NumPy, the Pandas, the Matplotlib. These are not present over there. Okay, with conventional Python, right? We have to install these packages one by one. This is but with anaconda or PyCharm, this kind of environment is designed in such a way so that they are having this package and they make your processing also faster. Means your processing also gets faster as compared to conventional Python ideally and all. Okay, so that's why we prefer those kind of thing like PyCharm, anaconda, this kind of environment we prefer to code in your system. But that needs a good sort of system, like you need at least 64-bit system, 6 GB of RAM, i5 processor, so that your system can work upon. Okay, so if you have installed, that's very nice. If you have not installed, I am recommending you two things to install in your system. Today you can install, and then you can use those things later on if it can be installed. First of all, anaconda you can install, and how, from which point or which website, which platform you have to install, that you should know. And second thing, you have to install Python 3.5. Okay, anaconda archive. We have to open Anaconda archive, not anaconda.com. Okay. In Anaconda archive, you are having a lot of versions available, right? Now you don't know which version to install. Anaconda 2, Anaconda 3, they used to update always, right? So I will give you one of the version that is so much stable and that I had used. Okay, because version you can install anyone. Later on we have to use packages and libraries and frameworks. So those frameworks and packages and libraries important plays the role. It's not the because every version is having some latest package, and so if we need to update, we can update by command line also. Okay, if you don't need to update, then we can work with simple. It basically uh, there are certain versions that are more stable that comes into the account that has a stable version has released. Here you will get the Mac OS, you'll get the software for Mac, you'll get the software for Linux, you'll get the software for Windows as well. So one of the version that I will recommend is over here, Anaconda 3 4.3.1 or 4.3.0.1. Okay. This version I found quite stable. This one. Okay. Anaconda 3 4.3.0.1 and Anaconda 3 4.3.1. I found it all the versions are good, but this version I found is quite stable, is having a good response, means as compared to any others. Okay. So I'm giving a link to it. This is 64-bit. You can consider a 34-bit also. Copy link location. I will paste over here. Okay. Any other version you want to install, you can use other version also. We'll check like if it is work and well and good. If not work, then we can continue with something else. Okay. So this version is having a good feedback, or you can say it's quite stable. So you can install this particular version. Second thing, we can install what? Python. Python, please install 3.5 or 3.6. Please don't install 3.7 or 3.8. Okay. That's why I'm saying, because there are so many challenges are there with 3.7 and 8. Okay. Then what happen, like you are working on some package, some framework, and that framework is not supporting 3.7, then again it will be a challenge. But with 3.5, everything is supported in 3. Each and everything is supported in 3.5. So 3.5 and 3.6 are the more reliable version of Python. So you can just go to Python and you can install what? 3.5. Okay. Where is it? This one. This is a 64-bit file. Later on you can install for Mac and all also. So two things I have given. Please install these two files in your system, and please install as administrator. I'm writing over here. Please, whatever things you're installing, please, 2 points I'm writing. First point, please install as administrator. And if you don't install, please don't come in class and sit in the class and then tell me that, sir, I'm installing. That will not work out. In the class, you don't have to install. And second thing, please install as administrator. And second thing you need to install while installing, do check add to path while installing Python as well as while installing Anaconda. It will ask, there will be option add to path. There will be a box over there. You have to just click over add to path option. Right? So how to install as an administrator? You can install something as an administrator. It's very simple. Sorry. You have to just right click on the setup file and then click on run as administrator. Is it clear? Everyone? Okay. Right click on setup file and run as administrator. Okay. This is how you can install something as administrator. Second thing, whenever you install, there will be option. You can, I guess you can all read. there will be option add to path. You have to just click over add to path. If you not click over add to path, then you will face a big problem in installing third party packages and frameworks and softwares. Okay, so on the third screen or first screen, on second screen, there will be option add to path in Anaconda as well as in Python. In both the cases, you have to select add to path option. You have to just check that particular box. Got it, everyone? Everyone, is it clear for all of you? Is it clear or not? Since you already installed, so it is clear for you. That's why you already installed, right? Okay, Harshit, please do install everyone. And tomorrow we'll continue with the NumPy, pandas, and all those things. Okay. As of now, I'm winding up the session. Okay, and tomorrow, I guess we will start by 2. Is it 2 to 5, right? What do you want? Is 2 to 5 is cool for you? Okay. Okay, 2 to 5 is better. Okay, fine. So tomorrow our session will start at 2 and we'll wind up at 5. Right? Okay. Okay, everyone, take care. Good night. Stay home. Stay safe. Thanks a lot. Shall we wind up? Yeah. Good night. Okay. Thanks a lot, Parthiv. Take care. Light the candle. Sure, Harshit, I will light the candle. Thanks. Thanks a lot. Everyone, take care. Thanks, Akhil.